Good afternoon, everyone. Today we're going to talk about section 5.5, application of inner product space. First, we are going to talk about the definition of the cross product of two vectors. Let U becomes U1i plus U2j plus U3k and V equals to V1i plus V2j plus V3k be the vector on R3. The cross product of U and V is the vector U cross product V, U2 V3 subtract U3 V2i minus U1 V3 subtract U3 V1j plus U1 V2 subtract U2 V1k. And here is the determinant form of the cross product of U cross product V. Let's place the I, J, K, U1, U2, U3 as V components, V1, V2, V3 as V components into the determinants. And it can use the cofactor expansions changed into the determinant U2, U3, V2, V3i subtract determinant U1, U3, V1, V3j plus determinant U1, U2, V1, V3k. And it will equals to the U2, V3 subtract U3, V2i subtract U1, V3 subtract U3, V1j plus U1, V2 subtract U2, V1k. And it would be same as the result of the definitions. And let's look at one of the example. Example 1, find the cross product of two vectors. Let U becomes I subtract 2j plus k and V equals to 3i plus j minus 2k. And first, let's find U cross product V. Let's put I, j, k, 1 minus 2, 1, 3, 1 minus 2 into the determinants, and it would be cofactor, and it equals to determinant minus 2, 1, 1 minus 2i subtract determinant 1, 1, 3 minus 2j plus determinant 1 minus 2, 3, 1k, and it will become 3i plus 5j plus 7k. And the second, we're going to find V cross product U. And again, let's put I, j, k, 3, 1 minus 2, 1 minus 2, 1 into the determinants. And it will cofactor into determinant 1 minus 2 minus 2, 1i subtract determinant 3 minus 2, 1, 1j plus determinant 3, 1, 1 minus 2k. And it will equals to minus 3i minus 5j minus 7k. And we can observe that from U cross product V and V cross product U, their final result is different and with one negative sign different. And now let's look on the geometric properties of cross product. First, U cross product V is orthogonal to both U and V vectors. Second, the angle theta between U and V is found using the values of U cross product V, and it will equals to the length of U times length of V times sine theta. And 3, U and V are parallel if and only if U cross product V equals to 0. So in this case, when you find the U cross product V equals to 0, you can tell that U vector and V vector are parallel. Fourth, the parallelogram having U and V as adjacent side has area U cross product V in absolute value. And now this is the parallelogram of U vector, V vector, and the angle theta. And we can find the height of this parallelograms equals to the length of V times sine theta. And if you want to find the area of this parallelograms, just put U cross product V into the absolute value, and you will get it. And let's look at this example. Example 3. Find the area of a parallelogram. Find the area of the parallelogram that has U vectors in minus 3i plus 4j plus k and V vector minus 2j plus 6k as the adjacent side. And let's first find the U cross product V in the determinant form. We put I, j, k minus 3, 4, 1, 0, minus 2, 6 into the determinants, and will equal to the value 26i plus 18j plus 6k. And find the area into, let's put u cross product v into the absolute value, and we can find out that the values into square root of 26 square plus 18 square plus 6 square and would equals to the square roots of 1036, and this is the square units.